Welcome everyone to this week's IPLD sync meeting. It's September the 14th. And as every week, we go over the stuff that we've worked on the past week and then discuss any agenda items we might have. And please add your name to the attendees list. I will post the hackpad also in the chat room for those who don't have the link, where we also put in notes if we have discussions. And I start with myself. So in the past week, I've worked again on the Rust multi-hash stuff and polished things a bit so that so currently I work on the tiny multi-hash, which is a fork of Rust multi-hash, and I tried to get it into feature parity with Rust multi-hash, and it's not the case. So today I've worked on actually making a merge request, which was smoother than I thought. And the only missing piece is that there is Blake 3 support in Rust multi-hash, which isn't yet in tiny multi-hash, but will come soon. So that's the missing piece, and then it's ready to be merged. And then we again have one upstream version, which hopefully then everyone will use. And that's also what I kind of concentrate on this week, to get this actually merged, and then also libp2p using it and IPLD using it and so on. Yes, that's pretty much it. Next on my list is Danielle.
Cool. So last week, I finished getting up to speed on the docs and specs early last week. I also sent a pull request with an exploration report on my experience getting up to speed, which is mostly what pieces I found confusing. And I also started a thread in the Go channel on Slack about moving the Go import paths from github.com/IPLD to our own IPLD.io domain, which has some advantages, such as being feature-proof. So I've started a draft of a more formal discussion of how we could go about this in that linked hackmd there. And with some help from Eric, I'm also starting to look at GoIPLD ADL HANT, which is supposed to be like an implementation of a HANT with the new IPLD prime library. So I don't have a lot to report there yet because I've been mainly reading the existing code and reading on this data structure. But I am making slow progress. But that's it for this week.
Thanks. Next on my list is Rod.
And not a whole lot to report for me this week. I haven't been well, and so not a high productivity week, but mainly working on this block storage API, which is meant rewriting the card library, basically, pulling it into pieces and then putting it back together again, with a much more modern feeling API doesn't have hangovers from some old abstraction that has got its history in places that no one remembers anymore. So that's working okay. I mean, I'm happy with the simplicity of the API, but this conversation with Ghazala about the dependency injection of the block and multi-format stuff is interesting and does impact it as well. I don't really know where that's going, although he seems to have an endpoint in mind, and trying to engage with that with him. And we've been having some other conversations about other JavaScript APIs that we'd like to see. But aside from that, nothing major to report.
Thanks. Next one is Eric.
I have not pre-prepared my notes this week, so I've been scrambling to remember what the heck was this week. I think it was mostly docs and specs and docs and stuff, and communicating about docs and specs and stuff. I have just yoked a bunch more docs into the docs repo about, I finally put the codex conversations in there. I did a little bit of high-level structuring and leaving some stubs for other things, included a table of contents over a bunch of stuff. So there's plenty more to-dos in there, but I hope that that skeleton is something that we can build upon usefully in the future. I had a couple more conversations with Ian and the PeerGolf folks this last week. They're doing some really fascinating stuff, and some of it, of course, grows to be application specific in a way that is very much PeerGolf logic and not something that we would be likely to do in IPLD alone, because it just accumulates opinions, especially when cryptography gets involved, as you might imagine. But they're kind of interested in making more of their libraries reusable around the IPLD data handling, which would be really cool because they are, of course, writing in Java, and I don't think anybody else on the call is currently maintaining Java libraries, so it would be awesome if somebody is taking that on. Talked a little bit about the challenges there. Java's got a strong type system that requires design discussions. Yeah, that's enough details for that. I've been trying to wrap my head more around the advanced data layout stuff, the ADL stuff. So both talking about that with Danielle, and also I tried to build a demo ADL that's the simplest possible thing. I tried to make a ROT13 string ADL. And so there's a branch, not even a PR yet, I should turn it into a more conversational format, but there's a branch in the GoIPLD prime repo which pokes at this and how to make the interfaces work and what to call some of this stuff. I did a little bit of work propagating library changes downstream. So Go GraphSync and the protobuf based repos that we have for GoIPLD prime both have PRs out for them now to get them up to the latest major versions of the interfaces. And Unix FSv2 got another round of drafting. I almost forgot until I saw Michael typing it into his notes. So thank you, Michael. Yep, trying to get that discussion moving along a little bit further. Now that we've got more and more grounding of like ADLs and how they fit into this picture, and like, oh yeah, directories are really just maps with this black box that handles the sharding. I think every time we go at the Unix of SV2 specs, they get a little bit simpler every time we do it. So I think this is the simplest one yet. And I guess maybe I'll let Michael talk more about that. So that'll be it for me.
Thanks. Next is Michael.
Hey, yeah, let me actually pull it up because there was a bunch of stuff on here that I've kind of forgotten. Okay, yeah. I fixed some bugs in the block API and in a bunch of our little JavaScript libraries. I went in and updated the FBL implementation in JS to the latest spec and all of our latest steps. And then I implemented Eric's new Unix SV2 draft, which is actually really pleasant and easy to implement, like the highly consistent version of it, because we're not doing any of the inlining. And it actually, it composes really well. It looks really well. One of the nice things about it is that a file is just an FBL. So it's just our flexible byte layout, which is really nice for reuse. It means that you can kind of take any binary object that you have, because the FBL schema allows you to inline the bytes as well. So you can really take like any binary representation, and now that's just a file. And so if you were to imagine us implementing that in the gateway, you'd be able to give it any CID to any FBL, and it would be able to read it as a file as well. And then, you know, on top of the file, we add the attributes as part of the directory structure and as part of the HAMP that goes into that. And when we keep it really consistent and we just make all directories a HAMP and make all files FBLs, then it's actually really easy to implement and really consistently hashed everywhere. So it's pretty nice. There's a bunch of places that we'll probably end up bike shedding on, but I think it's a nice direction for the spec to go in. And I was really happy with the little implementation that I did. Then over the weekend, I started poking around at a podcast client. Wanted to write a little podcast client that would basically live in GitHub. And so it's using DagDB and the new GitHub Git LFS stuff in DagDB. So basically, it'll every hour go and look at all your podcasts and then pull all of that metadata into the database. And then it'll generate HTML for the entire application. And then it's just a static website that you pull down. And then in the static website, you can, in a service worker, pull up all of the data and then actually map on top of that all of the data that you're in your player and all that kind of stuff. So it's like it's an interesting approach to like a distributed app that just kind of lives in GitHub and takes advantage of some of the GitHub Actions as like kind of a cloud service, but much more personalized to each individual. So that's been fun to poke with. I ended up adding a bunch of features to DagDB. Just using DagDB right now like surfaces a lot of things that like could be nicer. So I've just been fixing that as we go. And the last thing that I want to talk about is probably something that we need to discuss like as a group, maybe towards the end. But I've been talking with a few folks about like what the structure of the team and the work that we do could be sort of after the Filecoin launch. And something that's been coming up is that the project framing is not great for what our team does. We work a lot on just data structures, and we work on IPLD and multi-formats and things on IPLD. And a huge part of what we're doing is like building these data structures and then dog fooding the data structures to figure out what's going on and collaborating with other teams that need data structures. And so, yeah, a lot of other people are in a similar boat where like the project framing is not working for them. But a couple things that I think that it's pushed us in the wrong direction or a little bit too far in one direction is like we've overly focused on implementations and not paid as much attention to the protocols. Like we're protocol labs, we're not project labs. And we have all these specs, but we don't have great tools around compliance. We have not done a great job. Like whenever anybody has like a new implementation of something, we're like, oh, why didn't they use our thing or whatever? We're not really thinking about it as like, no, these are really simple to implement protocols. We should take it as a sign of success when people implement like another multi-formats thing or another IPLD thing, and just kind of integrate that into our view of the project better. And if they're having problems, like we've seen people having problems like encoding CBOR, for instance, because DAG CBOR is so restrictive, we should be prioritizing building better tools and better specs for them to deal with those compliance issues, rather than just trying to funnel everybody into a couple implementations that we've written. So yeah, I've just been kind of unwinding that a bit and thinking about that. And it's like a framing for the team and the project that I think that we could probably do with some discussion on ongoing for the next like few weeks at least. And that's my update.
Thanks. I think that's it for the updates. Johnny, do you want to say something?
Oh, I think you're still muted somehow. It says Zoom that you're unmuted, but I don't hear you and I see you talking. You're set up for like a full podcast. I don't know why we can't hear you.
Yeah, sometimes when my computer goes to sleep, it puts the mic to sleep because it goes through the hub. But
okay.
so just to dovetail on what you just said, I think so I'm having a major challenge with the DID specification, so the decentralized identifier, and mostly has to do with this CBOR. So they're threatening to drop CBOR support from the specification because I can't represent CBOR COSE keys properly. And the challenge is that it is a mixed media types. And so I can't express it completely in CBOR. And I can't, because we don't have the full int as key represented in like the DAG CBOR's DAG COSE representation. And the challenge, I think, and we talked before with like 3box and whatnot about this, the use of a IPLD link and actually basically using a CID, with that CID might be like a base 32 with a ED25551 public key multi-codec, and then just the bytes that actually goes after it. And so the challenge is that there's more metadata that actually has to wrap that, including like an ID field, a type field. And so it also gets into like a bike shed naming problem, which is like, what do you call this attribute that the link is a DAG COSE public key? And also the challenge is that in COSE and CBOR, or even in COSE, CBOR signing and encryption, there's no tag for a public key. It's actually application specific. And so like you have to define it in your application. So there's actually no key, no tag that says, hey, this is CBOR, and this section of it is actually is the X and the curve, et cetera. And so it's so, and it mostly has to do with mixed media types. I'm trying to advocate, let's just keep it in JSON serialized to CBOR, in which case it's just key value pairs, and the key could be string. And basically you could do JW keys, JSON web keys, as JSON, but in serialized to CBOR. And let's just start off with that. And so I'm getting major pushback as far as like the DAG CBOR stuff I put in, which is basically IPLD. And I wrote a bunch of stuff for just generic CBOR with explaining how things could be expanded using tags. But they're like, oh, well, this is like, no one's really using this. And you need at least 3 implementations. And like, hey, listen, I've got IPID, which I created. I wrote the specification myself. Those guys in Portugal, remember those guys? So, and then there's another guy who's in like Germany or Austria who actually created like a VR app that actually is using IPID. So, but it's talking about bike shedding and like standards process is like, it's just so frustrating. So, how can you guys give me some help?
So I want to back up a little bit and make sure that I understand the problem. So if I recall where we landed on DAG COSE was that when you use the DAG COSE codec, it's just a regular COSE with a binary field that you're signing, and the binary field is a binary representation of a CID. It's assumed to be a CID.
Yep.
Like that
Just
was
payload.
where we landed.
Yes, the payload section. Yeah.
Exactly. And then if you want to do anything else with COSE, you just make it use the COSE codec instead of the DAG COSE codec, right? And so, but they're saying that they want more, so they need to be able to sign something more than that?
No, so it's about actually this whole thing about cryptographic agility is that you want to represent your keys. So the DID specification is all just basically publishing your public keys. So, but there's this whole like library of naming shit that of like describing verification method JWK 2020. It's basically like we created this thing. We're calling it special. We named it in 2020, and it has a very specific purpose, which is DID authentication, and it's represented as a JWK. And they want me to do a one-to-one mapping of this exact same thing, all in CBOR, to represent the keys. So it's yes, eventually it's about signing it using the keys, but the DID methods are about publishing your public key data. And there's this whole field of cryptographic agility of declaring the type of key, at the class of key and the type of key. So it gets into linked data signatures, RDF models, and just by naming things, you invoke it, and it has special meaning.
So this sounds like a COSE issue more than a DAG COSE issue, right? Because is a COSE basically saying that you can't have all of that metadata in the key?
Yeah, so you need to wrap it, and so the challenge is that you can actually basically create a COSE key representation, a COSE key format, but and that's which is fine, which is basically you're doing it as int as keys with parameters and etc. and x and y and don't use D because D is for private keys. So all right, so you have this blob. Now there has to be this way of actually saying, hey, this thing that I represented in CBOR as COSE, this actually has some special meaning. It's basically and there's something that they did suggest is public key multi-codec, and I think that may be where we land. But the challenge is that that multi-codec is really it's a multi-base multi-codec, because actually a public key multi-base is like hey, this is in base 64 encoding of a ED25519 public key, and here's the public key bytes represented in that.
I just can't help but feel like there needs to be some layering here, and that you can't take every problem and put it into the same layer in the same spec, which seems to be what they want to do.
Right.
Like this is like why you have separations of concerns.
Yeah, and I think it's, so I'm mostly trying to settle on like, hey, you guys want to do JSON LD? All right, cool, that's fine. We can do that. I can do JSON LD on top of IPLD, basically adding an at context, and it has some magical purpose, and the attributes are, even though suddenly actually like from a cryptography standpoint, like suddenly it's mutable. It's a mutable external dictionary, which means that all I need to do is do a man-in-the-middle attack and basically trick you to reroute the signature to a different field or a null field. And in many cryptographic libraries, null equals true. So like there's going to be this huge security vulnerability years from now. And anyways, that's good. That's going to be a topic for my my DEF CON meeting next year. But in the meantime,
I wrote the spec. Here's how you hack it.
Yeah, exactly. That's exactly what I'm going to do.
I don't know why they want to ruin their specs so much. Like I don't understand this standards body.
No, and Juan warned me when I this is like 2-3 years ago. He said, like, are you sure you want to do that? Like he even actually offered to pay me to support me to do this. And I said, no, I got it. The piece of cake, man.
Famous last words.
Right. Yeah.
Oh man. No, I mean, yeah. I don't I still don't understand why the int key became a requirement at some point in there. Like why did that happen?
Compaction. I suppose compaction, and I think the did document doesn't really need to be compacted. I see verifiable credentials.
The people that need to name everything explicitly for every explicit use case are worried about fucking shaving bytes off of the keys on the fucking map. What? Tell
me about it. So I think mostly I'm settling on, all right, you guys want to do JSON LD, that's fine. I'm going to do a more robust, like ideally that at context, because I argued for it can be a URI, not just a URL. So basically that left a footprint for IPFS : / or ideally IPLD : / but you get to like a routing problem is like if you branch it, like, you get this issue as far as like naming conventions, as far as like I added a middle name and your schema only had first and last. Are we talking about the same middle name that you talked about? And so, but that's more sort of routing problem. But and the at context, I think I have a way of actually basically creating IPFS or IPLD and the at context. So basically it's now an immutable reference to the dictionary. And that, so I think at least in my libraries, I've actually satisfied that. But it's, so mostly I'm just dealing with this mixed media type, and I'm okay with strings, byte string as keys. And actually I left that in the specification. And there's this thing called CBOR LD, CBOR linked data, which basically you describe an external dictionary. And that basically is a map of attributes and to ints. There's also an algorithmic approach, which is basically you sort those maps by magic, and then you basically, this one is 0, this one is 1, and it's based on your sorting algorithm. But then again, like it's ultimately it's vulnerable to, well, how did you sort it? Did you actually get the right external dictionary? In which case you could it's open up to vulnerabilities. No, mostly just I appreciate you guys listening to me, bitch.
Yeah, no, it sounds like kind of a disaster.
Yeah, it's so frustrating because I finally got it into the specification for both the describing CBOR with tags and then specifically DAG CBOR with CIDs, and I pointed to the tag 42 and I said, hey, and we can do signatures and we can do DAG COSE signatures this way, and also the key ID would be the did key URL, and it will point and say you can actually go fetch the public key, etc. But this is the last thing I'm stuck on, which is, and they're giving me like 2 weeks, otherwise it gets pulled because they want to go to CR, candidate release.
Can you just clarify something for me, because I'm not like up to date on what's been going on here at all? Are they mostly just hung up on the fact that they need to type everything and that there's no like inherent, like, we don't have like a type named thing of like, oh, here is the schema that refers to this data, and they're all like really happy to use like HTML links for things? and we don't have like a CID. We don't have a way of using like a CID to describe a schema and then like call that a day. Is that what's holding things up?
Yeah, mostly because actually it's just like this dependency on JSON LD, and which is all mutable HTTP links, and that is that's where the web of the semantic web fell apart, which is basically they're not persistent, and they're really not URLs, they're URIs that describe an identifier that defines a thing, and so and when that description is offline, then you can't have logic in your semantic ontology. And and I think there has been some discussions in the IPLD world and of conversations with RDF models. And I think there's even actually a commodity codec suggested for RDF. But the challenge is that RDF by nature actually has cycles in it. So it gets into some concern as far as, it's not a DAG RDF model, it's a cyclic RDF model. And so many of these actually have cycles that are, again, you could get lost into an endless loop, or they change, they're mutable, and they're not persistent.
I mean,
these
from the point
schemas are
of
supposed to have cycles, or is this like an artifact of because everything is mutable, they could have cycles?
Yeah.
The latter, they could or they should?
They could have cycles, they shouldn't, but a lot of them are self-describing, that you get like this thing and it says, oh, as I'm talking about myself at this and it uses a fragment identifier to describe the ID within my own document.
I see.
So
I remember talking to Manu about this maybe like a year and a half ago, and his answer to but it's mutable, what happens when the website goes away, is like, oh no, we swear everybody has the website cached locally.
Right. Well, that's
which seems like, couldn't you just use a static identifier, and that would be, and like use a CID and call it a day?
Yeah, and I think what I've actually suggested as far as like the JSON schema, which I actually did a lot of like just the validation of the document in JSON schema, where the JSON schema identifier was the hash of the document with the identifier removed. So that basically like you're creating a new hash, but it's okay because you basically can self-verify that this document is the identifier, and it's just assumed. So but here I can share my screen and show you the document, and maybe give you an example of, am I sharing? Yeah. So here's the CBOR section that I created, and this is CDDL, markup language notation. But basically what I did is, here's the, in the CBOR pretty print export, which is basically the CID, the did document is basically this is just strings. These are text, a created field with a date timestamp. And in CBOR, this could be more concise with a tag that would be specific for date. And the same thing for like the public key. So here, whatever identifier, and here's where they actually like to do like type. This is an DSA public key type. I think actually there's a better example. So here it is basically in JSON. So here's the verification method as an array, which is an object, and it's basically explicitly stating the type information. And then I had wanted to use links in this as basically CIDs with maybe DAG DAG CBOR, because DAG COSE is about the signature aspect of it. Anyways, but this is actually where I put that tag, like here's a COSE signature with a tag 42 with the byte, which is basically the CID. So that's where that falls in. I don't know any thoughts as far as like, I'm also all alone because like they say that there's no one really sort of implementing this. And so this approach with the DAG CBOR despite it being pretty straightforward.
Yeah, that's unfortunate. I mean, I know that there are folks that are using Jose and Kose with some of our stuff, and that's driving the DAG Jose Kose conversations, but I don't know anybody specifically doing a bunch of DID stuff. I mean, no, that's not true. So there are people putting DID information into IPFS, but I think they're putting them literally into files and things that look like files.
So it's the ion or element is basically is using IPFS with a whole bunch of blobs that you have to get an algorithm to go through, and it's stored JSON data. I thought IPLD was actually much more elegant, and I think it's a solution to it. And it's also I'm really trying to be all immutable hashes. Everything there's no mutability in it. There's even the context is actually was going to be immutable to prevent.
I think we've even.
Just to clarify, the Microsoft people, like the Ion folks, I think are pretty willing to do IPLD stuff. I think they just weren't really exposed to it. And that was just like, UXFS is just the easiest way to get anything to move around.
They did everything the easiest way, and then they've been adjusting now as they've got gone to production. And so, we pointed them in the direction of IPLD, and they're pretty into it. So I wouldn't be surprised if it moved in that direction. Yeah. But other than that, I don't know. I have a hard time with the semantic web folks. Partly because I wasted a bunch of my time there in the 2000s, and so I don't. I like still have like some PTSD about it or something. But it's just, there was this vision for a data layer for the web, and at some point, they compromised on not a data layer for the web, but a serialization layer for the web for semantic data. So they became very comfortable with the idea that databases are going to exist and they're going to silo information, but we're just going to have this serialization layer that presents all of that information to the web in a semantic way for people to get more value out of it. And I don't think that model is really going to reshape the web, and that's not really a data layer for the web. And if you're going to build a real data layer and build real data structures and databases and file systems and these things that people need, then you need structures that are more stable than like these JSON documents with mutable links in them that can be fucking circular. Like that's crazy. Like you can't build stable structures that way. But if you live in that world and they're really comfortable in that world, then it's hard to have these conversations. I don't know.
But is it hard for them to get you? Like, maybe I'm misunderstanding, but as long as they give you like a URI, right? As long as every time they have a mutable link, you can replace it with an immutable link, and then you can just call in your little world of things, all of their stuff is like invalid. Is that not sufficient? Like, as long as your thing is a subset of their thing.
Yeah, so it still gets just into this a naming problem. So here's I think I put something in. So it's let's see if you can read this. It's probably not formatted right, but basically here, let's say it's an object, and this is a part of the DID document, and it's a verification method, and that has an array of objects, and that object is a type. In this case, it's a verification key, just generic. It has a controller, and right now I'm saying it's a public key, and this is going to let's say a base 32 encoded link CID, which is an ED255 public codec, and basically it follows, and actually the public bytes is basically in line. So sorry if it's hard to read. Yeah. Oh yeah, this because it's yeah. So here's a faked version of it. So it's there we go. And so I think it's ultimately just about naming. It's about bike shedding, which is that we have some special name for this type, and this public key. What they're wanting to do is basically say that it's a public key multi-codec 2020. And something that has special purpose. And it's basically like it's somehow registering that into a registry that says, oh, what follows is going to be that type. And I think, but it's going to be a never-ending battle of actually maintaining and keeping up these registries up to date. And who maintains that? That's not really a sort of a scalable solution. It's also very centralized into in this case described in the at context.
Okay, I think I finally got it, that basically the key name defines what the type is. And you want to have a different type than they want to have there. So therefore they say you need a different name because it's not the same type.
Yeah, and that can be done in the at context. And so I suppose like, so that would be, and I would actually want to have this as IPLD. Actually, no, this would be, because it has to be interoperable, they don't let me do an object link like that with a CID. So I actually have to create this as a string. That's the must. And that would be, I am suggesting, at least right now it's supported as IPFS, but I think IPLD, and then that actually would be then the CID. And then in that document, that context describes what these public key multi-codec 2020 is. And then there's a human description of it, and that can be then parsed. And oops, you get the idea.
That's somewhat reasonable.
But mostly it's just going through and actually having to, they want examples of all of this in CBOR. And I'm like, well, CBOR is nice. We don't need to do that. Intest key is nice for compaction, but let's just get to agreement. But now like JWS has its own public key mechanism. IPLD will have its own mechanism. CWTs will actually have their own. PEM, those public key PEM encoding is going to have their own. There's one for X509. I don't know, mostly that's where I landed, which is basically I have to create these as JSON LD description or add them to the registry, and they have special meaning because the link is going to be a CID, and that CID I think yeah. So let me share my screen again.
I have a quick question. What I don't get is like, isn't the whole point of the context that you can interpret the content differently? Like, I mean, like, so you have the context. So wouldn't it make sense to have the same key names because the context defines how to interpret the key names? So why are the key names specific to the context? Is the question clear? Sorry.
Yeah. So mostly it's kind of like trying to boil the ocean as far as like just naming things, and like it's like this cryptographic golem is what I accused it of. It's basically like you're invoking its name and it gives life to it. And so I think, but that's all it is. Like you're basically just declaring it. And because the charter says that they're not allowed to create new cryptographic algorithms, and this is where it gets interesting, like declaring ES256K-R defines the signature recovery mechanism of Ethereum signatures. So that is basically a new thing. It's in the Ethereum world, yeah, but basically it's recovering the signature with an extra byte that's not registered in IANA. It's not registered in the JWTs or JSON Web Signatures. So it basically it's this new thing, so, but they're getting around it by naming things, and And then this ability to have cryptographic agility by saying that there's verification methods, that this type of key is only used for authentication. It's not used for signing a credential, for instance. No, I spend too much time talking about it. But I appreciate most of you guys listening to me bitch. But this example at the bottom is basically, this is all just basically key value pairs. So the CID in the public key multi-codec is basically just describing the curve, the key type, and the X coordinate for, in this case, ED25519. In which case, I can just do that in JSON. So there's actually no reason to do that. That could basically be done more simply and elegantly. But we have to get agreement as far as the meaning, the semantics of, if I just give object with curve ED25519 in this information, like we need to know that that is a public key format.
All right. Are there any other things that people want to discuss or just give updates or?
I mean, if people are cool, I could tell them a little bit about my looking around at what caused me to send that message out about you know, how you might have alternative proofs other than just a hash for what data is. Basically, there's just a lot of content that already exists on the web and that people have found through other mechanisms, right? They found them through websites, they found them through wherever. And even in locations where there is already like a SHA-256 of the file, there's no way for me to know how to find it over IPFS. And similarly, we have things that are, we'll call it like, we have codecs that we sort of are not fully compatible with, and that, you know, get objects are happy to be 100 megs, but if we refuse to send blocks that are more than a meg, then things stop working. And there isn't necessarily like an easy answer for this. But even if you were to go through all of the work of finding like an alternative cryptographic proof that makes this thing self-certifying, that says this old thing can also be represented as this new thing, I have no idea where we would glue it in our stack. You could glue it in as a special multi-hash. You could glue it in as a codec. You could glue it in as an ADL. It's not clear where any of these things would fit. And so I guess the question boils down to, if I had a long self-certifying thing, so not a hash, but something, not like a 256-bit hash, but something longer than we would feel comfortable calling a CID, what would be, do we have any interest in representing those things, and how would we consider doing it?
What is the reason that they need to be the identifier?
I go to the Ubuntu website, I find the SHA-256 of an ISO. I want to know if the data exists on IPFS.
Okay.
Yeah.
Okay. Yeah. Yeah.
So I don't understand what the cryptographic proof is that is asserted as being a primitive that we have that can do a thing that we want to do.
I guess here are two examples. I give you a magic snarg that proves to you that SHA-256 of file equals the SHA-256 of all of the leaf blocks that are referred to by the CID, right? That's like the magic snarg approach. Another one would be
That sounds like something that I want, but it doesn't sound like something that, how do I compose it? And what does this thing cost to produce? How hard does somebody have to want to lie in order to make this do the opposite of what I want it to do? And like, how can I prevent that? I don't understand how to compose any of this, or if this primitive even exists.
Well, maybe here's one that's like a little easier and a little more like, it has problems, but like, I guess something you can wrap your mind around a little more. I could build like another Merkle tree, whereas I'm slowly unwinding this thing, right, all the way down to the root, to the leaf blocks. I also include the intermediate SHA-256 hashes, right? Because the thing is a Merkle Damgard construction. I can just glue these things together, and exposing intermediate state isn't great, but you might be able to use that to gain some confidence that actually this new DAG represents the same data in the old DAG. So now I have two CIDs that can refer to the same content, as long as I'm willing to have some sort of understanding that same doesn't mean the same DAG, but the same leaf nodes glued together, because I have some definition of a context that's important to me.
Right. I believe that somebody can do such hashing and then produce such a tree. And then I believe that you could compose another document which refers to both of those hashes. And then I could, of course, hash that because I can hash anything, and that's always a primitive that we have. But I don't understand how that document is supposed to let anyone else trust my claim. Like, I just hashed this random ass claim that I made, right? And so I don't.
So like if I were to find, I look up an advertisement, I say, hey, does anyone have this thing with this SHA-256 hash? And they respond and they say, I do. It's actually represented by this DAG. And here I've submitted this proof that shows that this half of the DAG has like, this half of the DAG requires these pieces of the partial of like the intermediate hashes. And then this half, requires these ones, and I can glue them together in the same way that you can, like I can try. I understand it's hard to describe this. I can try and write it up more like formally so we can talk about it later. But the point is, like, even if the construction exists, right, and it takes like a meg to represent, where do I stuff this thing, even if it were to exist?
Well, no, but I think that like the use case really matters for where you would want to stick it. Like why you're doing it actually really does matter in terms of where you want to put it in the stack. And I think one of the reasons why I'm having a slightly hard time with this is that there's just better ways to do this if you're building something from scratch. So that sort of inherently means that if you're doing this, then you're doing it to integrate with some kind of legacy, right? Like a bunch of people have these ISOs that have this SHA on them. And so we want to integrate with all of those external systems, or those storage systems, or whatever they might be. And so we've constructed this way to bridge them together. Because if you were just doing it from scratch, if you're just building out a use case where like, hey, I want people who have parts of this to be able to share it, and I want to be able to like know when we basically have the same data. If you're working with the FBL byte list stuff, you can reuse each section of the byte list really easily, and then you have hashes for every single part of it. And so you have like you basically have the ideal hashing for validating each part of that data in whatever network and whatever people that you pull it from. You don't have to map some external context on top of that and then reconstruct a hash for some like random slice of the data that's being represented. So there's like a better way to do that with the primitives that we already have. So if you're building what you're talking about, it would literally be because like, oh, people already have this ISO and they're already seeding it by some kind of hash. But even in
not needing pre-agreement, it's about not needing like pre-agreement. So like, let's say I go and I don't know, let's say NPM has a list of the hashes of all of the binaries they distribute, right? but I can't convince I can't convince everybody who publishes on NPM to also publish an IPFS hash. And B, I can't convince NPM to like chunk up everything and dump the IPFS hash there also. So what I say is, given that you trust NPM and you therefore trust that this hash is the file you're looking for, is there a more efficient way is there like a peer-to-peer way to find this thing?
Right, but what you're talking about now is you're building Google for the distributed web. You're building an index you're building a metadata index over what everybody else is doing with these hash links. So like that is effectively, you know, Google for NPM on IPFS, right? Like you're just indexing some data that exists inside of these structures so that you can give people like access to the actual CIDs that they can then go and pull the data out of the network.
Except untrusted, right? Right, like the reason why we have block sizes that aren't a gigabyte is so that I don't have to download more than 1 meg of stuff without knowing that it's garbage and then banning the peer, right?
Yeah.
The other approaches of like, oh, I'm just advertising that like, by the way, this graph happens to equal this 100 gigabyte file, I swear, doesn't do that because I have to download the whole thing and then hash it to see if it matches.
Yeah, I mean, I know that you can do, again, like I keep having the hardest time with this because like I know what some of these proofs can do, but the use cases for them are so narrow that without really understanding what they're being used for, I have a hard time figuring out where we fit it in.
I want to make a weaker statement than that and ask for more information. I do not understand what these proofs do. The word proof has been used and is extremely magical to me in this conversation. And
I would like to set up a structure.
That trust is part of this, right? And trust about denial of service is part of it. But I don't know what kind of proof can give me this thing that I want. And I have heard other people in our periphery say, for example, oh, ZK snarks can do this magical thing that I definitely want. And that is the amount of information that I have received from somebody who is making that claim. And I do not believe it without massively more detailed substantiation. It's too desirable. I don't believe it without a heck of a lot of detailed proof.
Yeah, so I can try and write up a little more some of the thoughts of the things that I'm familiar with, as opposed to the things where I would like need help on like what cryptographic mechanisms make sense. But in terms of what is the definition of proof that I am referring to, it is, I would like a way to prove the statement given a particular interpretation of the relevant pieces of data. These two graphs are equivalent to me, and I would like such a statement to be interpretable by downloading no more than 1 megabyte at a time before knowing the whole thing is garbage. Those are my two requirements.
I don't know if you can necessarily get it to 1 megabyte, but just like pretend for a second that a torrent file is a snark, right? Like it literally says like, here are all the slices of the file and here's all of their hashes. And then if you ask people for that file and they're like, oh yeah, I have that. I have a different data structure for it. Here's some of the data. As long as you get each piece of the data in the torrent file, you can reconstruct and rehash to figure out if it matches each of those hashes, right? And then this torrent file is going to be less than a meg to download the proof. And then you would have enough data to, yeah, I mean, you're probably going to download a little bit more than 1 megabyte of data from people, but.
So if you had, let's say they were, let's say the whole thing was some sort of like, you know, rolling hash where I can just like add them up together, like the addition of like 4, you know, if I add them in the correct order, they add up to the correct hash, right? Then sure, I could do that. You could give me a torrent file with a manifest with sub things and I add them up in the correct order and everything works. But our primitives don't work quite like that.
No, no, right? No, every sub thing in the torrent file has a hash. It breaks up the file into parts for each hash. So you would have a bunch of hashes for each slice of the file. And those aren't going to exactly match like a UNXFS file, but you can download that part of the Unix of this file and then take that part and hash it and see if it matches the hash in this file.
But they don't match the thing I got off the like. They
Yeah,
don't
I
match
mean, like
the
the
thing I
raw
got
data.
from the place. Yeah, right. This is
The
the
raw
thing
data.
is that, you know, if I go to a random place, I go to like one of these antivirus guys, and I know that they published that the SHA-256 of this file is good. Okay, cool. So the only identifier that is content-based and not website-based that I have for this thing is a SHA-256 of the whole file. That's all I've got. And I need to somehow turn that into a thing I can go searching for on a peer-to-peer network.
We have only 2 minutes left for the meeting, so just in case someone has anything else, last chance. Or I also see a new face, so in case someone wants to introduce themselves really quick at the end of the meeting. Sorry for not chiming in earlier.
Hi, can you hear me? Can you hear?
Yeah.
So I'm actually a PhD student in history and anthropology at MIT. I'm not a tech person, but I've been following different projects that aim to in some way decentralize the web. And everyone who I talked to told me about IPFS. And in order to get familiar with your project, I decided to attend your meeting first, which is very, very difficult to follow for someone who doesn't know coding. But I've been trying to. It's basically like listening to a new language that you don't know, and trying to learn it by just listening to it. But yeah, that's me.
Thanks. Yeah, I also have to say that, like, especially this meeting today was extreme. Like, normally I would expect the meetings to be easier to follow. So in case you want to chime in next week again, feel free to join again. It's probably easier. Like, this week was really like, yeah.
And thanks for
tough,
making this open to public. Thanks.
Yeah. Cool, thanks. All right, so we are at the end of the meeting. So thanks everyone for attending, and yeah, see you all next week again. Goodbye.